So first of all, again, I'd like to thank Atlantic University for hosting me, and this will be a really big pleasure for me to talk about something that I've been working on since the last 4 years. So who am I? A bit introduction is that currently I am a senior mechanical design engineer working in an automotive industry. So the company is in US, but I work from Bangladesh. So which is like, so, okay, I have been from, so admit some people. Okay, so I work from Bangladesh, which is like 12 hours time difference is there. So
wow. Okay.
You guys can understand that yesterday there was a shift in the daylight saving time. And that's why I had to reschedule this whole lecture after 1 hour, because I had something in the last hour. So I'm truly sorry for that.
No, that's okay. That's okay.
Okay, so let's move on to the lecture that we are going to discuss today. And today's discussion will be mainly on a few topics, which is mainly talking about how physical products are made. So from scratch, which we say that design process, to finally the physical products which comes in our hand, which is finally manufactured and sold to us. So I'll be discussing a brief overview of the whole process that goes into making these products. So first of all, I would like to talk about the design, then a design process, then we'll talk about user-centric design, also some mechanical aspects that goes into designing, and then some of manufacturing processes, and there will be an interesting case study and also some bit information about what's going to happen in the future about this mechanical engineering and product design. So are you guys ready? Okay, I think everybody is muted, so I'll just start the lecture. So first of all, I want to start with a brilliant quote from Thomas J. Watson. He said that design must reflect the practical and aesthetic in business, but above all, a good design must primarily serve people. So why do we design, by the way? Like, there has been so many designing and so many updating of some things which was already existent maybe 1,000 years ago. So we keep on designing to improve things, and our main goal is to serve people. So people feel easier to use that, people feel nicer to have that. So all the things relate to people, and when people need some products, only then they will buy that products. If the people doesn't need them, no matter how much engineering goes into a product design, it will not be sold. So our primary purpose should be making something that is people-centric, that means user-centric. So that's something which I'll discuss throughout this lecture in a bit small gaps. Okay, so first of all, let's start with some academic concept like what is design. So for example, these Lego bricks, you guys might be familiar with. This is very common thing that you can find for kids who plays, not only kids, in university level. In my first year of undergrad, even I had to make a robot with this Lego. And so this Lego is a really popular thing. But do you guys know like what goes into the engineering and design of this Lego? They might seem like a very simple thing, but the product design and the engineering that goes into making these things is really complicated. And that's why the company, you can say that, is already a $50 billion company. So no other company has attained that, like in this Lego business. So Lego is itself the company, and their trademark is Lego, and you can find that embossed into their every products they have. So currently they have a lot of different products, which is not only like a square or rectangular cube that we see. Okay, so some terminologies. Let's start like so design is basically the process of planning. So whenever we make something, we need to plan before making it. And you can say that design is the process of planning for the construction of an object or system. it's not like the only a physical product has design. It can be some building also might have a design. It can be a software application which can also have a design. That means planning for everything can have a design, right? So this design in engineering terminologies, why we separate this as an engineering design, because to identify solutions for problem which needs technical knowledge, okay, technical know-how. Let's say if I want to make a automobile, if I have only software related knowledge, I'll not be able to make a car, because a lot of different concepts of physics will be going into making this solution. So that's why when we are talking about engineering design process, our planning needs to have some sort of engineering techniques implemented so that we can think of how to solve a solution. Okay, so next thing that I want to discuss is that engineering design purpose. So what's the purpose of this design? Okay, so the main purpose is to solve the problem that we already talked about. So the second purpose is using technical knowledge to solve the problem. So not like the knowledge of guess, or maybe we have some different knowledge from different field and we try to implement in engineering design. It will not be viable, because you already know that, like, let's say I have knowledge of cooking, only then I can make a good recipe. If I have a good knowledge of engineering, it's not like that I can measure the right amount that can be having a good taste in a recipe. So similarly, whatever the problem is, we need to have knowledge, like specific knowledge about that domain. And I think Dr. Wilson might know already, like, so when I talk about domain, so there is a lot of domain in this world, and people who try to master one domain maybe finally gets to do a PhD in that domain, and then he becomes an expert in that domain. So sometimes we need some experts also to contribute in the design process, so that they can tell us about the problems that we might going to face when we are in the middle of manufacturing that object. Okay, so this is kind of like the purpose of engineering design. And the last thing that I didn't say is that whatever solution that we come up with, it needs to be acceptable by the customer. Okay, so we can't escape that. So whatever the problem may be, and we make a solution, if the customer doesn't approve it, we are not going to sell it, and the whole designing process will not be accepted, right? So we have to take these three things into account. So next we will talk about a bit the engineering design process and the cycle that goes into this engineering design. So so what are the process that goes into engineering design? The first thing that is that we define the problem. So let's say there has to be a point where we know that we are trying to make a product, but what is the main problem that we are like hoping to solve? Okay, so I'll give a basic example. Let's say we wanted to build something. So people wanted to build something that a guy with no legs can sit on and also travel from one place to another place to like to fill in the gap for having no legs. So a person who doesn't have a leg, or maybe some problems in the leg, so he can't walk. So we are trying to make something that could be used as a chair. And then the problem was like having something which can be used by a person with no legs. So that's the problem. And then finally, people try to find out a solution for that, and they came up with wheelchair. So that's how we define a problem. So we try to find problem first, not the solution. So obviously, problem will come first, not the solution. So secondly, we try to explore if there is already some good solutions that we have for this problem. If we already have them, then we don't have to waste that much time into research and designing and maybe analyzing a lot of this problem. Because it could be that most of our problem that we are trying to solve is already solved. Okay, so I also work as a freelancer and I get a lot of clients. So I'll also define, I'll also talk about this in details in the coming pages. So next we have to talk about establishing the specification, and then we'll be talking about the conceptual design. So there is one design and there is another thing is conceptual design. So it can be in form of hand sketches or something like that. Then there is CAD software where we put that conceptual design into more concrete design, which we can see virtually and which we can feel like a physical thing. And then we run a lot of simulation in the virtual world. And finally, we want to test that thing. So we build a prototype in the physical world. And then there is a lot of testing also done, and we note the results. And the results are then iterated, and we try to analyze the results and communicate with the problem definers or the clients, and then we try to think of if the results are like acceptable to them, or maybe they are thinking that the customer might accept these results. And if there is something redone, if there is something that has to be redone, then we'll be again going over this whole process. So you can see this is a cycle that we can continue again and again. And so one thing that I want to say that design is an iterative process. That means we cannot solve, it's not like 100% time we can solve design only running through this cycle one time. So there might be like 5 times or 10 times we have to run through this cycle again and again until we find the most viable solution. So that is actually this design process. It's not like only a single cycle. We actually might have to run this cycle several times. Okay, so now I'll discuss a bit broadly about these things, because these are very important to understand why we are doing this. So first of all, like there might be a lot of people to define the problem, or maybe only one person has identified a problem and he's saying that this problem might have a really large number of people who might want to get this problem solved. And if this problem is solved, maybe they will buy our product. And if someone only comes with this problem and to a guy who knows how to solve this problem, or who can understand, okay, I can relate with you and let's start making the product that you're thinking, then you can say that that point is defining the problem. Now we'll be asking that, okay, can you define the problem further? So he'll be basically defining what is the main problem. So I'll give a practical example that what I worked in the last year. So I had a client who came with an idea that he has a robot. So he has a robot that can clean the solar panels. So the robot runs through the solar panels and he can clean, the robot can clean that stuff. But the problem is that the robot can only clean the solar panels if all the solar panels are put together, lined up in a like a same plane. So that means the robot doesn't have to go from one plane to another plane. But the problem starts when a really big roof has several places where solar panels are there, but there is a gap. And in that gap, the robot might needs to go down in that gap and then again rise up into that other solar panels. So just a realistic problem. He told me that if it can be solvable, then we tried to find some solutions for that. And I'll just say that the solution was that we tried to make some kind of linear motions so that when the robot was at the edge, so he had some sort of landing mechanism. So he safely landed over there and then again tried to rise up above the other solar panel. So we tried to test it also, and that testing is still going on. So we are not still finally, we haven't launched it yet. So that's something I was talking about, like defining the problem. So problem could be very small problem, but it might have a really huge impact on people. So what impact could that have happened if this product is launched? The impact I can think of is that the solar panels are very important for us. as in we are in a need of renewable energy. And you guys know that our future depends on renewable energy, and solar panels are the #1 renewable energy source because we have the sun, which gives light for almost 12 hours. And if we can utilize that, I think the whole world can have this crisis solved, right? The energy crisis can be solved. But in order to do that, we need to find a more efficient solution so that the solar panels can be taking the solar energy and converting them more efficiently. So what happens if it's covered with dust and some materials which are not like wanted over on the surface? So the sun energy is blocked by them. So we don't want that. So a daily cleaning or maybe at least weekly cleaning is very important for that. So how did I explore for that solution? So when my client shared that idea with me, I was trying to explore that in the internet, obviously, because we don't have any other source rich enough like the internet we have today. And in future, maybe we are going to have a lot of debate between that, what kind of search engine our future generation is going to use. Nowadays, we're using Google. We might switch into something really, really powerful, because you know that the emerging AI technologies are making a really big turnover in these technologies. So exploration is something very important if you are going to do this research, or if you're going to find out a solution which might already exist. So let's say what it could happen that I propose a solution to a client, and end of the day, after we have a meeting, we can find out that actually this product already exists. And if we don't find that way, it could happen that after we do all the things and we manufacture the product, then we find out that this product is already available in the market, which is even worse. So exploration is really needed. And there is another very important thing that we have to explore and research, because there are several patents which are available. So that we can have like legal issues that could happen if we are making something which is already patented. So that's also something we have to take into account. So if we are trying to patent our ideas, we need to find out if this patent is already available or not. So that's what is exploration. So next, we try to find out some specifications that we might think that this could work in our product. So let's say you guys know your smartphone has a lot of specification, and every smartphones are having different specifications. Some might have a different camera resolution, some might have a different camera resolution. And this is part of the product design, that we try to specify what our product is going to have. So there is a lot of different things that we need to think of when we are trying to specify our product. It could be dimensionally. Let's say we want to have a product which is a very small size, or it could be very big size, or size which we can like hold it with our hand grip, which is not too big, which is not too small. And we could also specify the color of that object or the color of that product. So a lot of things could be specified. And if we don't specify all these things, what happens is that there is a communication gap. And then when I make the product and the client says that, okay, I don't see that thing I want. Now there will be a lot of editing and going back to the engineering design process, and there will be a lot of time consumed for that. So people who can specify a product very nicely, I think the most important thing of the engineering design process will be this specification, because the next things like making CAD design and making the conceptual design are very easy. So here I skip the conceptual design and I just merge it with the CAD, because in this CAD you can understand what actually the computer, how we can use the computer softwares to make a very detailed design like this. So what happens that in conceptual design, you are only making some sketches and you are finalizing the specifications only, but it only comes alive when you're trying to make that in CAD software. So glad that we have CAD softwares nowadays, but 20 or 30 years ago, they didn't, the mechanical product designers didn't have CAD softwares. So all they had to do is they had to make detailed sketches, which would be almost like the things that we are making it easily with the CAD. But they used to make those details in hand, and I've seen that how long the process was when it was done previously. But nowadays, these software solutions are getting more efficient, and it can guide you to this process to make really awesome technologies and products that we couldn't even imagine 10 years ago. So these CAD softwares would be something, a very separate thing to discuss, and it could be kind of like a hot topic for mechanical designers, the CAD software itself. But today I'll not go into details because we have a lot to cover. So you guys can see a picture over here is actually a exploded animation of a product, and you can also do this kind of animations within this software. So you don't have to find another software to do this kind of stuff. So next thing that I will talk about is simulation, which is a very important part. Let's say you can see a picture of a mechanism that goes into our bag. So there is kind of this mechanism in our like everyday bags, and this is used, and you know that like there is a capacity for that structure to like withhold that force that goes into that mechanism. So we can do this simulation in the software called ANSYS, or there is a lot of different softwares as well where we can do this. So we call this simulation type is called FEA, which is finite element analysis. So it's kind of like mechanical stress, how much mechanical stress is obtained for different type of materials and different type of forces. So we do all those physics and mechanics things in this kind of softwares. So previously we used to do all these handwritten stuffs. So all the handwritten stuff like structural engineering and mechanics and statics, all these were done previously in handwritten, and there were sketches, there were mathematics behind it. But now software engineers have blended these mathematical rules and principles into a software where we can virtually simulate a product that we are making. And this makes the product designing process foolproof when we are trying to make the prototype. So we'll not have to iterate the prototype for again and again. So let's say if we didn't have access to this kind of simulation, we might have needed to change the material several times until we get the perfect material for us. But the simulation saves us a lot of money and time as well. So the simulation is a virtual way of testing the product, but prototyping is more like a physical way of testing the product. So here is just a toy, but here you can see prototypes are also not used, are not developed by using final materials. So we try to make a prototype from scrap materials. So that is a very important thing to note. So when we are trying to make something of full scale, but we want to test it by our hand or by the looks of our eyes, we want to feel it, how it feels like, can it solve our problem or not? So we try to develop it physically. So nowadays 3D printing is a really hot topic, and we try to use this for prototyping a lot, which I'll also cover in the manufacturing parts. So the prototyping is very important part of this whole process, because here you finally get to see what your whole engineering idea is bringing. So it's kind of like a halfway of seeing the fruition of your whole plan. So this is not the final one yet, but this is the first thing that you see physically. So the next thing that we do is the communication, the testing also has some results, right? So we don't have like tests without results. So the results are the most important part of the test. And these results are noted in a different variety of ways. We try to make graphs from it. We try to understand that what will be our optimum, what will be the optimum performance of that product that we are trying to achieve. So that results, let's say if the results are not up to the mark that we want to, then we might have to tweak in between the design so that we try to get we have those results that we want to. And there has to be some communications as well with the clients or the stakeholders who are, let's say, sponsoring this whole product design process. So we have to have detailed communications, and we need to get their feedbacks, that what they think of these results, what they think of the prototype that we made, is the solution viable or not. Now, obviously, in the first go, it doesn't happen, and they give you a lot of feedbacks, and there will be a second run of iteration, and you make the design again. But maybe in two or third or maybe fourth, it will be you'll have a result which is more likely to have a good product. So this is kind of like what the engineering design process is. So I have discussed it very briefly, but in future, maybe if you guys are interested, we can go into more depth of it. So now I'll be talking about some interesting stuff. It's mostly we are talking about user-centric design. Now, user-centric design, as the name says, that we are talking about people-centric design. So let's say if I make a design, then the design has to first take my as a user, it has to take my emotions first, and then we have to talk about the technologies that can be used to solve the problem. So in user-centric design, before talking about it, I want to talk about this product, and I guess everybody can understand what this product is. This is the iPhone made by Apple. And do you guys have any idea how many phones, only these iPhones, have been sold till date? So it's almost 2.24 billion approximately. These are the number of iPhones that have been sold. So it's not the money they generated, it's the number of iPhone they have sold to date. So you can understand why this product was really so fancy. At the same time, it solved a lot of problems for people, so that people were ready to buy this. Now, here you have Steve Jobs talking about you have to start with the customer experience and work backwards towards the technology. And this is very important, because you might have a lot of technologies, and if you think about making a product using that technologies, you might not have a product that will be acceptable by the customer. So you have to always think about the customer experience at first, and then you have to work back towards what technology you have to solve those problems, rather than boasting about the technologies that we have and we try to put them together and make a miracle solution. That won't happen. So Steve Jobs had a session where he was saying about this, and I think some of it might have came up in the Apple, and that's why Apple became a blockbuster product. Okay, so what was that user-centric design process that goes into that system? So first of all, that empathize is a very important part of that whole process. So what is empathy? Empathy is if I'm an engineer, but if I want to think like the user, so for a couple of minutes, I need to become that user. And if I am that user now I have to think that what problem that user is facing in the current product. Let's say when Apple was built, it was a smartphone, right? Now, the problem that they were feeling at that time, that the phone was having a lot of buttons. And you guys know that we were trying to make the phone like our computer, but we will not be able to have buttons like the keyboard, right? So having a lot of buttons was getting more complex for people to use, but there were some phones devised by Nokia and other Motorola that they had a lot of buttons in their phone at that time. So people were thinking that no, this thing has to end. And Apple was the first people that they made this touching technology. So like you have this smartphones, first thing was that the touch panel. So you have like with your fingers, you can touch a screen, so which is called a touch screen, by the way, and you can just navigate through the whole mobile. So whole screen you have is like you don't need a mouse, for example. So with your touch of your fingertip, you can have a mouse of your own. So that thing was kind of like the breakthrough. and people always goes with the first movers. That's why Apple had an advantage over it. So they were the first movers for this technology. But the main thing is that they felt the problem that people were having, so which was empathy. By empathy, they tried to understand that what's the most important problem that we can solve, which could make a lot of people come and buy our product. Okay, so let's say there are a lot of problems, but also you need to find out that what's the most what's the biggest problem, and then you have to prioritize that problem by their by the problem itself. Okay, so we can't have a very small problem which can generate a lot of money. So we have to think about bigger problems which is felt by a bigger customers, like let's say customers, where when we are thinking about all the customers, then only a solution will come when we are thinking like this touch screen and other things that the mobile brought in, which kind of like changed the whole mobile industry. And I love that's why I put this quote in the first place. So you might have seen this video of Steve Jobs talking about this product itself. So I just love that video. If you guys haven't seen it, I would suggest you to go and search for that video. I think that's really famous in YouTube. So next we come to define. So I already talked about defining a problem. So in this design thinking process, our next thing will be defining the problem. So we think about the user experience and think that what the user usually experience as a problem, and then we define that, okay, we need to act on these problems, and then we try to ideate our solution, and again we try to prototype it and test it. So you guys already know what prototyping and testing is. So that's the difference in the normal engineering design process and the user-centric design process. So I hope I'm not going too fast. So you guys wanna let me see. Okay, so yeah, I think I'm on the track. I'll just quickly go back to that page. So we have covered the design thinking process. Now a bit boring stuff is incoming. So this is mechanical aspect of design. So this is more like when we're talking about actual technical knowledge, then what technical knowledge goes into a designing process will be over here. So now I'll just roughly go through it. So as the final product is a result of mechanical design. So we can't ignore this. So we have to make a design which is functional, which is also safe to use. Let's say if we are talking about smartphones, you guys know that there is a lot of safety that needs to be ensured, because these products are used by kids. Also, when we are using it, maybe a kid with maybe even babies are near that product. So we have to make this product as safer as possible. So there were some incidents for that. A lot of companies were penalized by their sales, right? So we also need to think about the reliability of that product, that how much reliable it is. Let's say the smartphone has to function at 100% at all the time. Okay, so it's not like that I have 10% charge, but the phone will function at 50%. It's not like that. So we have to think that the reliability as well. And there is a competitive nature of it, because let's say our product solves a lot of problems, but are we going to compete in the market or not? That's also a very important part. And for business holders, since these products are made by businessmen, that's the most important thing, that will this product be competitive or not? So it's no denying about that. And the usability of that product, that how much time I can use that product, and is that design. So the design also needs to be manufacturable, because let's say I can come up with a really fancy design, but end of the day, I'm really upset that I'm not able to manufacture this, because there is no technology for manufacturing that design. And that could also be a thing that we have to consider in the early stages. And also we have to think about how marketable will be that product, because marketing is also a very important part of the business. So I have listed down some of the things which actually talk about that same things. but these are more in appropriate terms. You can say functionality, strength, and safety, cost, manufacturability. Yeah, so cost is also a very important thing. Let's say if I'm going to make a product and it's not affordable by the people that I'm targeting, so there is a target audience, and if it's not affordable by them, then I'm doing something wrong. Okay, so if I want to make a product which can be bought by anyone, then I also have to think about the cost in that way. And if I'm only making a product like a car that Bugatti makes, so they make a really expensive car, but their target audience is also a very few millionaires or billionaires. So in that way, they are okay with that. But let's say if I want to afford a Bugatti, I'll never be able to buy it. And if they are also targeting me as an audience, then they are looking in a different place, right? So they have to think about the cost in also a way that, so like why the designing phase also needs to consider the cost, because for making that product, you have to spend the money. And if you are making the product and if you're spending a lot of money making it, and then the problem is that you will not be able to sell it for that price, and you will not have any profits, rather you have loss. So that's why it's very important. And the weight is also important for most of the products that we use, and we have to ensure, is it user friendly or not? Then the shape of the product, the aesthetic nature of the product, and also we need to think about the volume of production. Let's say if we want to make a product that we're only selling 100 of those, then the manufacturing technique might be a different technique to manufacture only 100 products. But if we are trying to make 1 million products, then we have to think about a very different scale of manufacturing them. So the whole thing changes, and we have to think about a different way of manufacturing that thing. So these are the aspects. So I haven't covered all the aspects of mechanical design, but roughly these are the most important aspects of the mechanical part, which goes into the designing process. Okay, so now our lecture will shift from design to manufacturing, and here I'll be showing you the cycle again that I showed it in the engineering design process. Now, you guys can guess something, that something is missing in this cycle, and the very important part is manufacturability. So I talked about a lot of aspects that goes into designing them, but the most important thing is that manufacturability. Let's say even if we don't think about cost, even if we don't think about aesthetic nature, but the thing that we design in the CAD is not always that we can manufacture them, because we don't have those technologies yet. Maybe in future we might have some miracle technologies which will be able to make all the things that a CAD model is able to like stimulate, right? So the manufacturability is a very important thing. In the last 20 years, I think this was more of an pain for the mechanical designers, but nowadays there are some technologies like 3D printing, which is making our life a bit easier to manufacture whatever we want, but still there is some limit. We are trying to encounter research and try to find some solutions for that. So what is manufacturing as in a definition? So it's a process of making a goods by hands or by machine, so that finished product can be sold to the customer. Okay, so manufacturing is basically the implementation of design. So in design, you are just thinking, but manufacturing, you are making it alive. And then design for manufacturing is a very important term for designers like me, which is a way to identify if the design is manufacturable. So let's say it will be really difficult to explain at this moment, but let's say if I want to make something like a round shaped ball, okay, so let me give an easy example. So if I want to make a round shaped ice sphere, but all I have is a tray of square shaped ice cube, so which can make a square shaped ice cube. So will I be able to make a round shaped sphere like with the water? I won't be, because it has a limitation. So when I put the water in the mold, which I put in the refrigerator, and it will only give the shape of an cube rather than having a spherical or like a round shape, a ball shape shape, right? So why is that? Because that thing has a limitation. So similarly, when we talk about a lot of manufacturing processes, and when you know the details of it, you'll understand that there is a limitation for each and every methods, and we need to think about them when we are trying to design it. So it's not like we are trying to design it and we designed and now we are trying to manufacture it, and then we find out that, oh, okay, so the whole designing process was botched up because we didn't take this into consideration, right? So we have to go back towards the design process and need to find out what are the processes that will be used or that might be used, and we have to consider them in the designing phase. So I'll talk a little bit about the manufacturing processes, which are very common these days. Some of our casting. So casting, it can be tracked back to like ancient century. So you guys know that ancient centuries people also use swords, and a lot of these swords were made from this casting process. So the casting, like sand casting, was a very ancient technique. So this could you could make a lot of things and stuffs that were used in the ancient century. Stuff like swords, like shields, armors, a lot of stuffs were made those days through sand casting. But due to our technology and our evolving, when we started making the aeroplanes and the cars, then a lot of the manufacturing processes were discovered. I'll not say discovered, but reinvented, because there were sand casting, then we had to come up with die casting, which is a more easier way to make lighter parts. So sand casting will give you a lot of bulky parts, but die casting is more more easier to make lighter parts. And lighter parts were very important for machines like the aeroplane itself. So you have to make everything lighter so that the plane can fly. And also the automotive, like the cars and other things like ships, also had a lot of parts which were made through this kind of process. Now there is machining, which came up when we could use computer for doing this mechanized process. So we had this CNC machine. The full form is computer numeric control. So we have this computerized process to run a machine and as accurately that human hand could never do. So you can understand this machining had made possible to make a lot of devices or a lot of products that we see in our daily basis at this point. So even the iPhone, you see, the iPhone has a metal back cover, and that back cover is made by CNC machining, and it is really precise that they had to drill a lot of small holes in it, but it would be really difficult for a human to make those things. So there is also molding. So molding is probably the most common thing that we have right now. All of our, if not all, most of our plastic products are made from injection molding. You just name it. Whenever you're going to shower, you are maybe using a lot of them. When you're having even some people are using chairs which are made from injection molding. Some of are from roto molding and blow molding. So molding is basically having a shape where you put a material and that material takes the shape of that shape, or like what we call is mold. Just like I just like I gave the example of the ice maker in the refrigerator. So that's a mold. And when we are trying to put water on it and we're freezing it, we're getting a shape that we are having that mold as a negative. So the shape that we're getting is a positive shape. So that's also kind of like an example of molding. And then we have sheet metal processes. I don't know if you're familiar with this, but there is a lot of sheet metal products also available, and maximum structures uses these sheet metal things, and we try to form it or we try to bend it by a lot of different techniques. And also there is some machines for that. And last of all, additive manufacturing is a very new thing, but it's not that much new also, but is the latest thing you can say. So in additive manufacturing, so all these other processes were subtractive. That means I had to cut from something. So I had to reduce a thing and I had to make it into the shape that what I want to. But in additive manufacturing, we slowly add layer by layer, and just like making a cake. So when we are trying to make a cake and we are trying to put some cream onto that cake to make some shapes or maybe some kind of design, then we are trying to add a small layer for that cream, right? So something near to that, not the best of analogy, but additive manufacturing is a layer by layer based process where you are adding material to make a shape. Okay, so I'll just show you some live examples that we have in our daily life. So we start with the left one. So the left one, you can see it's not made with plastic, right? Or is it made with plastic? So that's a transparent plastic that the bottle is made of. So I would just like let you guys do some guessing what it could be made of. So the plastic product, you can guys, you can guess for a minute like what this kind of products are made through. So the plastics, usually they are made from molding, but this one is usually made from blow molding. That means there is a kind of air that goes into that mold and makes that shape very thin and very strong as well, because the design is made in a way that we have a stronger structure. So you guys can see that in every water bottles, there is a place where there is like a rib-like structure. And that is very important for the structure to be very strong. So that's something we consider in the design phase. And then the second product on the right, top right, you can see in the top middle. I don't know if you guys see the pointer, mouse pointer. So this product is also a water bottle, but this time this is not made from plastic, but this is from metal. And when we are trying to make something like this kind of shape from metal, we try to use die casting, that kind of technologies. And the right hand side, this is just a prototype version of like a arm prosthetic or maybe something exoskeleton kind of product. And this is made by plastic, and you guys can guess that this is made from additive manufacturing, or we call it like 3D printing. And on my left, top left and the bottom left, there is some products, very commonly used automotive products, and these are also made by either sand casting or die casting. So what is like difference between sand casting and die casting is that the amount of precision comes in die casting, but the sand casting is a bit less precise, and we have to refine it through some kind of sanding, or we have like grinding process to refine that process to have a better surface finish. So if we want to attain a very precise amount of surface finish, then we go into machine, and which is this process. So this process, you see a lot of gears and a lot of different components are made. So this is made through CNC process. So this is very precise, and you have a really smooth surface for this kind of products. And the last picture that you can see, this is actually a sheet metal product, which is like a paper. Let's say you think of a paper, and then you fold the paper to have that shape. And that is kind of like the similar thing that goes into the machine, where we just put a sheet of metal and then we try to bend it the way we want to bend, and we have like a drawing for that to guide us that where we have to bend it and where we have to put this kind of stresses, how much stresses, how much angles, and then we come up with a product. And the product becomes like this, maybe, for example. So this is also another process called sheet metal. Now, all this process that were covered, now we have a small case study to solve. And this is a very interesting thing, that because the company that I have been working for the last 1.5 years, so this is the exact thing that I am actually doing over there. So I am the design lead for that company and making some CNC process for them. And so this case study kind of like was attained, was like given to me, and whatever I have been doing, kind of like solving this whole thing for a year and a half. So you guys can take note of this problem, and I'll give you guys 2 to 3 minutes to just understand what this problem is, and then I'll go through that and we'll also solve it together. Okay.
So I do hope every participant is reading the details of the case study proposed by Muhammad Al Fayshal Shiraj, talking about a camper van building shop that makes about 3 vans per month with a handheld machine, a handheld process. Like Shiraj put it, each van requires $15,000 in materials, and the labor cost per month is about $30,000. Rent and utilities are $5,000. The price of each van is about $50,000. What is the profit made each year? Beautiful case study. I wish I were that skilled in the world of business, but I love that. Everybody likes money. So go ahead, ladies and gentlemen, try to come up with some type of response for our awesome presenter, Muhammad Al Fayshal Shiraj.
Okay, so I think you guys can take note of this question, and also I'll present the solution for this question. So this question you see is divided into 2 parts. So one part where in the top part where I'm talking about the company without the current technology, the CNC machine, without the technology, how they used to operate and how much profit they used to make. And the second part talks about, now if I am going to implement a new technology in this business, now I want to find out that how much time will it take me to recover the cost that I am putting for bringing this technology in. So that's the main basic of the problem. So I talked about a camper van company. So they are making like vans, recreational vans. You must have seen those vans, like the vans where in the inside you have like a room-like structure. You have a bed, you have a kitchen over there, you have a lot of stuff. And when you go to places with that van, you can have a really great vacation, right? So that company makes like 3 vans per month, and the process they're using is like handheld process. So handheld process as in they like a usual carpentry process, which requires saw and like drilling machine and all those things to cut and drill holes. And finally, they assembles everything together and then install it into the van. Okay, now each van has a material cost, each van has labor cost, and there is obviously rent and utilities. And then also there is a price for each van and how much they sell it for. Now, the first part of the question, the answer is in here. So the total price of 3 vans are approximately 150K, and the total overhead per month, so 3 times 20K. Now, why I put 3 times 20K is that, okay, I think some of it is not, oh, okay. So there is like 15,000 in materials, and labor cost is 30,000 per month, and the rent and utilities are 5,000. Okay, so that's why you can see that the 5K will come into your rents, rent and utilities, and 30K will be your 3 months per month labor cost, and 15,000 will be your here there will be a correction. It will be 15,000 for your material cost for 3 vans. So that will be 95 it's here, but it will be like 90K. Okay, so the total gross profit will be around 55,000 for that whole month. I'm talking about each month right now. Now, the second part is saying that if the company uses a CNC machine, now obviously that machine has a price of itself. Now, there is a information about that, like $60,000 is is the value for that CNC machine, and they got it for auction. That's actually what happened for my the company that I work in. So they got that machine for a really bargain price and a very cheap price, but the usual machine price is more than 200K or something like that. So that machine has a price, but there is also another price is like I added that will be also like 60,000 that is needed for the R&D. Now that R&D is something that I was actually talking about from this whole lecture, that R&D is also part of the design process. When we are making a new product, we call it inventing a product. But when we are trying to develop a product which is already there in the market, just like the mobile phones are already there, but the Apple brought a new type of mobile phone. So someone invented mobile phone, but that is invention. But people are now doing R&D, that means researching and developing. So R&D is very important part, which is like engineers and designers like us came into this process, and we tried to find out how we can implement our things that is done by hand, and how can we bring it to the CNC machine. It's not like we bring the CNC machine and whatever was done by hand will be done by the machine. It's not like that. So it's a bit difficult. We have to think about the whole designing and all the way to the assembling and also installation. And then we have to make solutions for that, which can go to the machine and they can do the process that were done by hand. So there's a lot of cost over there that I've added, and you'll be finding that in the second part. So again, let's assume the operation of the CNC increases by 5K, because now CNC will take a lot of electricity and you have some increasing utilities. Now overhead price will be increased, but you have something around this, and the total gross profit you'll be making about this. Now total investment of the CNC is something you have to think in a different way. Like the total investment was 120K, but now the difference in profit, that means previously I was making this much, now I'm making 20K more. So that difference in profit is taking 6 months for me to have the return on that investment. So that I was talking about. So I have 120K spent on the product and also the technology, and that is within 6 months I kind of like recover that amount. And from that upcoming month, that 20K difference in profit is my new added profit, and my company can carry on this process as much as we want. And this doesn't finish yet, because we were only talking about one CNC machine. Now we can buy a lot of different CNC machine, and we don't have to do the R&D anymore, because once in a lifetime you have to do the R&D, and when the R&D is done, you can buy as many CNC machine as you want, and you can produce as many vans as you want. So let's say if we have a really big demand of van that we need to produce, let's say we have to produce maybe 30 vans, then we can just buy a larger facility and a lot of CNC machines, and we can do this again and again with obviously a better profit, and all of these things will be adding up to the business. So this is one of the case studies for manufacturing cost, actually. So the cost is very important, as I said, for a business. So this is how it looks like in the real world. Okay, so I'll talk a little bit about the future as well, because you guys want to know that what's the future holding for this mechanical engineering and product design. So just a small glimpse of some photos that is produced by some AI. So it's really amazing that how AI can be used to produce this kind of ideas. So you guys can see this, the first two pictures are for a mouse. I was very surprised that the second mouse that you can see is having some kind of joystick. Okay, so I was actually approached by a client for a freelance project where he wanted to make some similar kind of design, but you have this AI already made this kind of design for you. So it's a very wonderful tool to use, but most of the people are now afraid that is AI going to take over the product designers? Because if they are able to create so much beautiful solutions, then why are not they be able to like replace the actual product designers? But as a matter of fact, I told you that there is a lot of things that goes into a product design, not just idea generation or making a design really look cool or aesthetic. So there is a lot of things that goes into that process. So a designer must need to understand each and everything and has to go through the process again and again. So I know that AI can help us to make better products, but AI will never be able to like take over the position of a mechanical engineer. Now, why I say that? Because there is some process which can be automated, but it cannot be taken over. Like they cannot think by themselves. So AI, as a student of AI, even I actually was not a graduate of mechanical, by the way. So I am actually a graduate of robotics and mechatronics. So I had a really great interest in AI, and I know how this AI works. So AI actually learns from people and try to find a solution. But it's not like solution they are generating by themselves. So even if you guys have used Chat GPT, which is really really hot topic nowadays, whenever you ask a thing which is out of the topic, then he will prompt a message and he will say that I was not taught that, because AI goes by the way, like there is a machine learning process. So it learns from us. So it's only able to provide solutions what human already knows. So human beings will be obviously on top of AI. And people who are seeing this kind of breakthroughs, and for some seconds, they're thinking that even I thought that. So it's nothing to be worried. Like even I thought that they might be able to take over some of the skills, but it will never happen. So in the same way, so I'll discuss a little bit about what careers and are there in design and manufacturing. And so you can see I have listed down some of the job titles that are in this design and manufacturing world. So you have this design engineer who is having overall idea about the whole process. So you will obviously need design engineer first of all if you want to design something. And then there is CAD drafter. So if you have a really big product, or if you have like a really detailed product, then you have different roles for each and every one. And so there are some separate roles for drafter that they are only involved in making drawings of things. And the design engineer will be mostly responsible for making the CAD models and all the other things that goes into making that CAD models. Now there are detailer, which is also a very important job nowadays. In LinkedIn, I saw that in one podcast, someone was saying that the detailers and the drafters are very important like jobs, by the way. And people who are doing it are really old age people, and now in the future they are dying, right? So we have to take over these responsibilities, and not many people are coming into these detailers or CAD drafting responsibilities, and mostly people are trying to go into design engineering, those kind of things. But we have to think about all these roles, because all these roles makes up the whole process. We can't skip role just like that, because if we skip one or two of them, then there is some problems that we are going to face in the long run. So I just talked about a few of the roles, but in general, when there is a very big company, they will have a variety of roles. Even they will have someone named as a battery pack engineer. That means that guy is only involved in designing a battery pack. And some guys might be only responsible for making a door for an automotive. So there is a lot of different responsibilities company can define. But in general, these are the roles that we have. So should I go through this process, or I think the time is already up? I'm not sure about that. Oh, okay, the time is already up, right? So I think I'll just finish my lecture, because this was already the last page of it. And so the carriers, so people who are trying to come into this design and manufacturing career, one thing I can say for sure, that designing and manufacturing will be there till there is physical products. So if there is physical products in our day-to-day life, then we'll have this field open for us. So there is no need to think that, okay, maybe we could only go to the software world and not think of the mechanical world, because mechanical world is the world that will bring you physical products. So in our day-to-day life, we're interacting with so many physical things. We might be thinking like the chair that I'm sitting, or maybe the desktop that I'm using, the mouse that I'm holding, all these things are physical products. And that's why I think that there is a really better, or if not better, there is a really good career outcome for people who are seeking to have interest in this field and trying to get a degree, or maybe even get a postgraduate degree in this kind of areas. So so by this, I want to end my lectures. There are some references where I took my some materials from, or some ideas from. And I'd like to thank Atlantic University once again for giving me this opportunity. And okay, I would like to pass my mic to Dr. Velsin if he has to say anything.
Thank you very, very much, Muhammad Al Fayshal Shiraj. I love the conclusion you drew as to remind our participants that everything we use is from that field. The pen that I'm holding right now, my watch, the television, I mean, the structure of this machine and everything around us is from design, manufacturing, design processes, mechanical product engineering. I thank you very, very much, Shiraj. And every day we come to that reality that those sessions are really outstanding, all of them. And yours is not an exception. You've performed your task of presenting to our family of Atlantic International University with a rare dexterity, skillfulness, and everything positive in between. So I am very, very grateful, very thankful to you, Muhammad Al Fayshal Shiraj. You've been of great use, really, for AIU. Thank you very much. However, this session is, of course, for our family, our students, our participants, even though we have run out of time already, but we do allow them the opportunity to raise some issues, ask some questions, and make some comments. So the floor at this time, ladies and gentlemen, is yours. If you want to ask a question to our outstanding presenter, if you want to know how you can take advantage of the future in the world of design, manufacturing, and processes, this is your time. If you hover your mouse at the very bottom of your screen, this area allows you to will allow you to ask your question or make your comment. I would like to ask Shiraj at this time to please stop the presentation so that we can more visibly see, thank you very much, the face of every attendee, every participant. And I remind you, ladies and gentlemen, that that menu at the bottom where you can see reactions, assuming, of course, that you are using a computer, but if you're using a tablet, the possibility is the same. I'm not quite sure if it's on a very small screen of a telephone, but if you, again, hover your mouse around that reactions icon that you see at the very bottom of your screen, you'll be able to see that hand, which allows you to signal to Shiraj, the presenter, that you want to ask a question. Alternately, let me also remind you that for those of you who are new, other traditional participants already know that the entire lecture will be available to you. You will soon receive a link which will allow you to download the entire presentation. We have the first question so far with Tibor Moskeli. Go ahead, Moskeli. You're free to ask your question now.
Good morning, Dr. Valsin. Good afternoon, good evening. All right. Okay, I think now I have two questions, but mainly now, the first one, when we're talking about the CNC machines, then Muhammad, the electric supply has to be reliable. So now, if you are in an environment whereby, I'm in South Africa at the moment, we're having issues with constant power supply. So now, if now you having load shedding, how would you maybe suggest one would go about that? Obviously now, trying to minimize cost of running a generator and alternative, power. Maybe just give us maybe an idea how to go about really running manufacturing plant in a situation whereby you have disruption of electricity. And then second question would be now around, you talked about limitation of now having, let's say, tools that you are using in design. And you mentioned Steve Jobs asserting that, okay, you start from the customer first and you move back. But he also said sometimes the customer doesn't know what he or she wants. Then you have to bring to the customer a solution that they never thought of. Sometimes now with the tools that we have, then how does one break out of the mold, so to speak, when we come to creative thinking in terms of design? What tools or what can we use except then maybe, our ingenuity in our minds? Okay, that's my questions.
Okay, thank you for the question. I really like both of the questions. So first question is a really big concern, like in countries where there is not a constant power supply. Now, what they might use, like, are they going to use these technologies or not? First of all, if any technology has to be brought, you have to think about the feasibility of that technology. Let's say if I just buy a technology and if I'm not going to be able to use it, that technology will not be, that buying will not be helpful, right? Let's say I want to go in my village area, and let's say I'm settling over there and we don't have any internet connection over there, but I buy a smartphone. That will not be a good purchase. Just like a relevant example. So you have to always think about what will be feasible and not feasible. Now, if you have a need of making these products, now there is a really good supply chain that we are trying to manufacture most of our, not only we, like we're saying, like most of the US is also trying to manufacture most of their physical products in China. And why they're doing it? Because they have more machines over there. They have a lot of different companies which are providing this kind of manufacturing, only manufacturing. So we do the design in US and we give them the design and they do the manufacturing for us. And they send it to US back again and we can sell them. So let's say if you want to do something in South Africa, and if you think that the whole overall, when you consider overall South African problems like electricity, and also maybe you might not be able to find people who are really like, let's say, people who are really reliable in using those kind of machines. Okay, if you don't have operators, if you don't have technicians, then if you just buy a CNC machine, it will not be a good purchase, because you have to think about what will happen if the machine, something wrong happens in the machine. We'll be able to solve it. if nobody in South Africa has never fixed a machine, then we can't bring it, and again we can't send it to the people whom we brought it from, right? So we have to think a lot of things over there. So there are, I know still there are small stuffs like there are different versions of CNC machines which are only doing maybe a fraction of the work what the real or like a really big complex CNC machine can do, which maybe the South African people or maybe some of the places they are using it. So I'm saying that, so you have to like counterbalance that. And if you talk about how to solve the energy crisis, yeah, so these machines, when you're buying these machines, it's a really expensive process in itself. If you're trying to make a manufacturing plant, it's a very expensive process. Now, if you can fund all this expensive process, you might make sure that you have a really good energy supply as well. And if that requires a bit of funding, you have to invest in that sector as well. So I think you got the point, what I'm making, that when I'm spending $10 on the whole thing, I can at least spend maybe $1 or $2 on the energy, which is the mother of running all this technology. If I don't have that, I'll not be able to run it, right? So like it's same like if I buy a motorcycle, but if I don't have the oil to run it, and if I don't have a backup for, if I, let's say, if I go to the petrol station, maybe someday they might say that, oh, okay, I don't have the oil right now. So if I just need that motorcycle to run, I might need to store something, backup or something like that, right? So you have to ensure how that backup will look for you. It could be in form of generators. It could be in form of renewable energy source like solar panels. Having a lot of solar panels could also maybe solve these issues. So I was working with one client where I saw that like the possibility of generating energy with solar panels is like huge. And I think our underdeveloped countries can utilize this. And mostly I think manufacturing, like people who are trying to manufacture things in a large scale, they should also take a step forward to run the whole manufacturing plant with renewable energy, because they have the ability to do that, right? If they consume all the electricity that the usual public will use, then that's not fair. In some like case that I'm thinking, like sometimes it's not fair that people who are really rich, they're not thinking about the people who are not even having the electricity 24 hours, right, running. So if we are thinking to take all the electricity for our manufacturing plants, that's not good. So if we try to make a really big manufacturing plant, we should devise a plan how we can make a renewable energy that can run our own plant as well. So I think that is your question number 1. And the question number 2 that you asked, actually I forgot that. Do you remember the question? I'd like to okay, I think it's muted.
If you want to remind Shiraj
okay,
about the second part of the question briefly, please.
Yes, please. It was now just being able to break out of the mold in terms of now thinking.
Okay. Shiraj, the molding in terms of thinking.
Oh, okay. So you were saying that let's say okay, again, can you rephrase the question? I think I need to get a better hold on that. Can you maybe you can type in 2 words about it?
Okay, sorry. All right, I think now it was mainly now, remember now we're using tools to design, right? And sometimes you are trying to design something that is not there. Remember, so bringing something that is now new, innovative. So now you then bridge that gap. Yes.
Okay, I got the question. Okay, thank you for reminding the question. So I was really into the first question that I forgot the second. So the second question that you're asking is that, let's say if I don't know something, let's say if I don't have any idea about something, how am I going to make that product? Let's say so that is what you're talking about, invention. So invention and designing are 2 different things. So let's say when we are trying to think about some problem and we know that we have some kind of technology that relates to that problem, then we are trying to then we're trying to solve a puzzle. But if we don't have the pieces of the puzzle, then it's very difficult for us to make that, right? So that's what inventing is. And inventing is rather a very difficult process and also a very lengthy process. So that's not like that doesn't happen just like that. So it happens over the years. So that's what happens by a lot of research. Let's say we are not seeing nowadays what's happening behind the scene, but a lot of these universities and their professors and the people who are pursuing PhDs, they are doing some sort of research in very specific niche, or you can say very specific field, where they are having a growth in an idea, or where there is like a small update which is not visible by the normal world. But those updates stack up, and at the end of the day, we have the technologies that we're seeing, and nobody has guessed that we could use computers. Like people 100 years ago never guessed that we could use computers, right? Because there was not electricity even. But these are very small improvements over the years that brought us to have this kind of computers, this kind of powerful devices that we are using today. So if you talk about inventions, let's say, I always love like one quote by a person that used to say that inventions doesn't happen just like that. It happens from outside thinking. So if someone is thinking outside the box, not only thinking on what technologies we have, you'll never be able to make inventions. So let's say there was a quote like the finest candle makers. So there are candle makers, right? Previously, when there was no electricity, there was only candle makers. So the finest candle makers wouldn't have the idea, could never come up with this idea of electricity. So that's one very true thing, that let's say how much fine my candles were, or how much very much like good design my candles have, I could never have that idea to make an electricity and make bulbs that we have today. Do you understand what I'm saying? Like only when I think outside the box, when I'm thinking what are the possibilities that I have. Now, people, obviously, those candle makers were not able to find that idea, right? The physicist, as you know, that we refer to Tesla, and we refer to other scientists that who came up with all these concepts, this theory, then somehow they were able to merge these concepts and theory into practice. And then slowly we had these evolutions in technologies. So similarly, obviously these kind of things people will never know, because people never knew the need of having bulbs or fans. They only knew that their problem is that they have to see something in dark. That's the problem. But the way to solve it is you either make candles, or you either make a thing which is more powerful than a candles. So that's the solution. I hope it gives you a little bit idea. Obviously, it doesn't answer the whole depth of your question, because if I want to discuss about that, it will take 1 more hour maybe, or more than that.
I fully agree with you, Shiraj. Actually, on the one hand, every such class session is by itself an encyclopedia. There is so much to say, so much to think about every class, about every field. So it would take an eternity to tackle every issue you bring up to our presenter. For that particular question that Mosikili has asked, Shiraj at some point asked for 2 or 3 words that would simplify the issue, and that combination of just a few words could be something like shape, mold, template. That's part of the question the participant was asking. Is there anything that universal shape or mold or template that could be used to build some of those designs. But the response by Shiraj is, we are not talking about invention. We're talking about going outside of the box. If there is some type of structure that you can think of, if you're gonna offer society the same thing, then you're just gonna be out of business. You've got to come up with something better, pretty much like Shiraj put it in his example. You look at the candles. If you're gonna offer candles too, then you're in trouble. The community is not gonna like it. The community is not just gonna go for it. You've got to think of something more powerful than the candle, and that's exactly what it is when it comes to design of manufacturing products, things of that sort. That's not my field, of course, but I do understand every little bit of the ideas that Shiraj has brought up. And once again, we are very, very thankful. I'm saying this on behalf of the entire institution of Atlantic International University, and on behalf of each and every one of you, the participants. I'm not quite sure whether tomorrow we're gonna meet at 10 o'clock Eastern Standard Time, pretty much like it happened in Shiraz's country, in the United States as well. We went for daylight savings time this Saturday night, and we have a new hour. It used to be 10 o'clock Eastern Standard Time in the last 4 or 5 weeks. But if there is a change, let's suppose that tomorrow it's gonna continue at 11 o'clock instead of the traditional 10 o'clock in the morning, then you don't have to worry about it. You all will receive a specific email letting you know about the change. But in the meantime, we are, of course, unfortunately out of time. And fortunately as well, the entire presentation by Al Fayshal Shiraj is going to be made available to you. You will receive a link, and that presentation, that live session will be on your computer for you to do whatever you please. On that note, ladies and gentlemen, I want to thank you again for your attendance. You've made the right decision to join us for this new live session. And of course, before we move away, we're gonna allow our outstanding presenter, Fayshal bin Shiraj, to say the last word, which I assume you all, ladies and gentlemen, are gonna like. The floor is yours, Shiraj.
Just there was one question asked by one gentleman. I just want to shortly answer him.
Go ahead.
Yeah, so I think Solaiman has asked a really good question, like if he has an innovative idea for an apparatus that can solve the mosquito problem, so what is he going to do for that? So that's what actually we discussed in this entire lecture, that the engineering design process is something we have to go through whenever we are trying to design a process, any product. So I think I can summarize a little bit in 1 minute. So if I have an idea and that idea is actually solving a problem, right? So that idea is our defining moment, like, okay, I want to make something, but how am I going to make it? Now then comes your research. We have to explore. Then we have to search, is there already some solution that's available to maybe other country? Maybe we don't have it in South Africa. And if it is in other country, how did they make it? And maybe we can get some sample of the design, or maybe we can get a product directly shipped, and then maybe we try to open it, reverse engineer from there, and try to make some product of our own, right? So we have to research and explore for products like this. And I'm sure maybe these kind of products are already there. And then what we have to do, we have to find out our design, how we are trying to make it and trying to sell it in South Africa. And then we also need to think that where we should manufacture it. Can we manufacture it in South Africa, or we should outsource the manufacturing process in China, something like that. So that's how we are going to invent not, I'll say invent or make a product which might be already available in other countries, but it's not available in South Africa. I hope your question is like somehow I could like just can go on for another day maybe on this topic, but I'm saying that this is how it should be answered. So I hope it's solved. So again, ladies and gentlemen, thank you for coming to this meeting, and I appreciate that although this meeting was scheduled 1 hour earlier, but you are still patient enough to stay with me. That really means a lot. And once again, thank you, Dr. Velsen, for inviting me for this lecture. And I really enjoyed making the lecture slides and taking this lecture. And thank you, everyone. I don't know where everyone is right now, but whatever it is, good night, good morning, or good evening. Okay. To all
all over the world. It's been a real pleasure and delight. I thank you. You've done the right thing, ladies and gentlemen, and our entire heart is to each and every one of you